Hello guys, in this video I'll explain you about this problem statement. The problem statement is we have to write a Pyspark code to find that customer who is spending more money to buy product. Okay, so we have to find a customer who is spending more money to buy products. So this is my data. So we have one data set. Let's think there is a Reliance store or there is a Walmart store. There are a lot of customers, but some customer will buy more product. So we have to find that customer who is spending more money to buy product. Okay. So this is my data set. So this is the our first column. This is the CSV data set. This is the customer order CSV. So in this data, first column will be first column. This is the order ID. Sorry, customer ID. This is order ID. This is price. So this first column will be order ID, customer ID. This is the order ID. This is the price. You can see that's 12. This is the customer ID. Sorry, this is the 14. This is the customer ID. This is same customer ID. So this 14th customer ID, that person with customer ID 14 is buying product multiple times. So for every customer, there will be some different order ID and price may be different or same. I don't know. It depends on the data. So we have to find that customer who is spending more money. So here in this data we have a 3 column. One is customer ID. This one the customer ID first column. Second is order ID, and this is the price. To solve this problem, we need only two. We need only customer ID and price, because we want to find that customer who is spending more money. Okay, we don't need order ID in our code. Okay, let's start writing the code. So how we can write the code for how we can write Pyspark code for this problem statement. So let me open my PyCharm. PyCharm, if you don't know how to configure PyCharm for Pyspark, you can go through my playlist. There is one video how to configure PyCharm for your Pyspark. Just go through it, and then it will be done. You can write Pyspark code in PyCharm. Now let's start writing our code. So we have to find customer ID who is spending more money. So first we have to import Spark context. From Pyspark import Spark context from also I will import one system from stdin. Okay, from system module import this stdin standard input. Why I am importing this I will explain later. This line here we are importing Spark context. Now I have to create SC Spark context. We imported that, but we have to create the object of that Spark context. This is our class. So we are creating object of the Spark context and giving that object name SC. Okay, sorry, control yet. What we are doing? It's the context. Just close it. Then here I have to pass two parameters. One is local master. We are saying that to our cluster or Spark engine that we are executing this job in a local machine, and to execute this job the Spark engine can use all core of this system. So for that we are using star. Star means all core, all resources available in this system. Sorry, local. And now we have to give. So we are executing this job in a local, and now we have to give a job name. Job name means we are assigning some name to identify this job. So top customer. You can set anything. You can write anything here. Top customer is my job name. Now we will create RDD. One, try to load that data. This is the data. This is my data. This is my data set. So I will load this data to our Spark cluster. This is my data. Okay, now sc dot text file dot, we have to give path name. To give path name, we will copy that path name from here, file path name, put it here, then change this last thing. Then we have to do a file name, customer order dot csv. Okay, customer order dot csv. This is my file name. Okay, so we are loaded the file in my our Spark cluster. So now the RDD has data like this, delivered data like this. So this the sc.text file will read data from this data set, and it will store the data in this RDD just string format. Like, let me write it, then you can understand. So our RDD will hold the data like this. Okay, it will be hold like this. Okay, so RDD will hold each record, each row from this dataset inside this list. Okay, now for our case we need only 2 column, but in this dataset we have 3 column. We have to remove column. Okay, so that we can perform our next thing. So we are creating a DD2 DD1 dot map. We are using map function. Why we are using map function? I already explained you in previous video. Okay, so we will write one lambda function here, and in the lambda function we will pass each record. Okay, so this map function will iterate this list, and it will pass each string statement inside x. So x will carry this thing. So it will iterate, the map function iterate, it will pass x in a once, then it will come here, the map function will pass this thing as a x here. Now we want to create a tuple with 2 column, customer ID and price. So we will create tuple. So we are giving a tuple sign here. Now what we can say, we are getting x. We want to try to split it. So there is a split function, split function, split function, and we want to split this string according to comma. So when we are facing, when so separator is a comma. When this function will hit comma, it will try to split that string. So now from this here, when try to split it, we will get a list. Okay, when you are using split function on a string, so that split function will create one list. Okay, with those strings. Okay, so we are getting one list here. So we are getting list like this. We are getting, if I give you some example, we are getting list like this: 14, 8703 and 3 comma 19. So after splitting, we are getting list like this. Now from here we want this and this. Okay, so that's why we will fetch the index 0. Index 0 means this customer ID. Again, comma, we are creating one tuple. So this is one thing. We are getting customer ID 14. We are getting customer ID from this thing, x dot split comma 0. Now again we'll write this x dot split it, this thing. 1. From here we are getting, sorry, it will be 2 because 2 is the this is the 2 because if I hit if we hit here, so 2 will be, if you can observe, the 13.19. So this is the customer ID, this is the order ID, and this is our price. So 0, index 0, index 1, index 2. So we want this 0 index and we want this price index 2. That's why you are from here. So x dot split will return on list. From there we are taking index 2 means customer. Index 2 means price. So now we are getting on list of, like when will this function will complete, we will get one list of tuple. It will be like this: 14 comma 14 comma 30.19, like this. It will be like this: 35 comma 64.89. So it will be, so we'll get data like this inside this RDD2. Okay, after the completion of this line. But one thing, we want to add the price. From here, this we are getting this 30.19. This price is string, so we have to convert it. So we'll convert to float so that we can add it. So we'll write the float function here, float this, and we'll put on extra bracket. Okay, I hope you understand this. This is inside the float function, this is inside the list, this is inside the map function. Okay, now this is done. So we are getting data like this. Now we have to add it. Okay, how we can add it? We have to use reduce by key. We have to use reduce by key function. So we are getting RDD3, RDD2 dot reduce by key. Here reduce by key will take two same key and then add the value of that key. Again it will take two same key and add the value of that key. I already explained you detail in the previous video, so you can check this video. Now we'll try to lambda function. Have to write a lambda function. So we are passing two key here, and then try to add the function, add the value of those key. Okay. So it is not a xy is not a key. It is a value. Okay. So reduce by will take two row, two record, and it will, and so when we are passing something inside reduce by key, so reduce by will reduce by key will take two key. It will find two same key. Then as a x, as a y, it will pass that value of the two same key. Okay. So, and then when doing x plus y, it will try to add those value. Okay. I already explained this in previous videos. Okay, you can check those videos in detail manner. I explained with example. I already explained those things in with example. Okay. Now we are adding those value. We added those value. Now let's think. I will add some extra record here in this thing. So if we have data like this here, so there are two same key, 1414. First, just two customer ID, so same key. It will try to add this thing, and this thing. It will try to add the value of this customer ID. So now if I write here, so RDD3 will hold data like this. So inside RDD2, data will look like this. 14, it will be 60.19. It will go away. So RDD2 will hold data like this. RDD3 will hold data like this. Now we already use, so we are already at it. Now we have to sort it because we want to find the topmost. Okay, that guy who is spending more money. For this we have to another function, sort by function. Okay, add4, we're getting add4, add3 dot, then sort by. Okay, so sorry, sort by will be small, so it is sort by function. Okay, inside the sort by function we have to pass one lambda, because in the sort by function, if you go to the definition of sort by, so let me open this web page. So this is the Pyspark documentation. You can go through this documentation. This is the sort by function. Sort by function will take one key value, and this thing ascending bool true. So by default, sort by function is sorting the value as a ascending order. It means 1, 2, 1, 2, 3, 4, 5. But we need descending order, because we have to find top person, like who is spending more money. So more money will be in top. Okay, number. So we want to descending order. Okay, so we have to do it as a false, because by default it's ascending order, but we want to do it as a descending order. I hope you know this logic. It is simple logic. You can go through this documentation. I'll share this documentation in this video's description. So now you have to pass one key. Key means by which key we want to sort this function. We want to sort this value according to price. We want to sort this data according to the price. So we will pass price as a key. Okay. So inside the lambda function, inside the sort by function, we have to write lambda function. Lambda. Let me write price. Let me write here. I can give some meaningful name. I'm not able to find meaningful name. What is the meaningful name I can give? Let's keep. I'm not able to find meaningful name. Let's think num list. Okay, this is the variable. Okay, from here let's write price. So we are passing the price, and we are trying to get the price column. Okay, this is price. We're getting price column. I hope you have to give false. Why we are saying like this? So this, when we are doing RDD3 dot sort by, so this sort by function will take whole list. Okay, and it will pass that list inside this price variable. Okay, so this price we will hold this list of tuple. Okay, list of tuple. So this sort by function this lambda function, this sort by function will iterate this thing, iterate this list of tuple. So it will go first this tuple, and it will pass this tuple to here. Okay, to here. And it will take the price column, and it will try to sort it, and it will give result as a list of tuple. Okay, I hope you understand what I am trying to say. You will try to sort it by the key. Key means what will pass here. Here we want to sort this data as according to this price column. That's why we are sending. We are writing here price and 1, because this is the index of this tuple is, this is the 0 index, this is the first index, that's a 1. So we are passing the tuple. We iterate this string, this sort by function iterating this thing and passing this tuple, individual tuple, and then try to sort internally. And we are giving this false statement because we want to sort as a descending order. By default it is ascending order. We want to sort as a descending order. Then we want to try to print the result. How we can do this? So we are creating a result variable here. Result equal to rdd4 dot collect for a in result for record in. I'm trying to give in result print record variable. Okay, now we try to save it and try to run it. I hope it will run. Let's see. It will take some time because it is a Spark cluster. Okay, now it is giving something. We are setting adjust logging level sc.log level. Okay, setting some log level. Stage means doing some processing. I will explain what is stage in latest video and in so we already got this answer. Okay, so something stage is happening. This stage 2 is stage 3. What is this thing? I will explain later. Okay. What is the meaning of stage? Some processing is happening. Then we are getting output. Okay, from here. See, 60 is the customer and this is the price. So the person with 68 customer ID, that guy is spending more money, and then we are getting some less money. So that's how we are solving this. And if I only want only this guy, okay, then how we can solve this? When we are printing, we don't want to list all those value. Okay, we are getting top value here, but only we just want to print this line. Then we can do like this. So when we are doing rdd.collect, it will give a list, and that list, in the list we are trying to access 0. Result 0 means top value. Okay, first index. In the first index there will be highest thing. Okay, highest value. But try to run it again. Okay, run it again. You can see there will be only one record, because from the list we are trying to access only one record. See, with 61 customer ID with 68 we are getting this value. So this is the customer ID who is spending more money, who is spending this much of money. Now see, we are saying they are setting the default log level to this. Okay, if you want to change log level, then how we can do this? So for this we can write here. Okay, sc dot log level to info. Okay, now run this. So it will try to give you more log. Okay, now we are getting only warning logs. So this is the extra thing I am saying you. And if I want to get more logs in my console in my this area, then we can change our log level. Okay, should log level. Now wait for output. See, to adjust the log level we are set log. See, we are getting info because we are added log level to info to get more information. See, some created broadcast variable, DAC, total execution, this number of tasks, total tasks is 2. Okay, that's how we are getting this. Okay, we are getting a lot of information what is going on internally. So you can change log label like this. You can change this log label to error also. So there's a info, error, and a warning. You can do like this also. This is the another log label. So it will show the logs if you are getting some error. Now we are getting output like this. Okay. Now one thing I have to explain. One thing I want to know that if you want to see the DAG of this code, you cannot see, because see this program is terminated. This job is terminated. To see the DAG, we have to hold the job. Okay. What I'm trying to say, if I go to my this thing and try to say localhost, not this, home system is hanging, localhost host 4040. By default, if you want to see DAG, we have to go to this. You have to hit this port 4040 port number. But now we are hitting this port, but we are not able to see the DAC because this job is stopped. Okay, you can see this job is terminated. So if you want to see the if you want to see the DAC, we have to, like, this job will be activated. Okay, if you want to see the DAC, this job must go running. The job status will be running, not terminated. When you are executing this job within millisecond, it will terminate. How we can hold this code? How we can put this job in a running mode until we say that now you terminate. So we have to use this thing. Okay, where I imported this standard input variable here. So what I have to do, I have to, at the last, we have to write this stdin did dot readline. This is the module. Okay, when we are saying this, we are saying that until I hit the enter button or something key, until you are getting some key input from keyboard, don't execute this code. Don't terminate this code. Not execute. So the meaning of this line, we are saying that until we are entering some input from keyboard, don't terminate this code. Now observe this. You have to observe this. Okay, this area. Now again I am doing run customer job. Now see, we are getting some output here. Wait. So it is executing our tasks. Stage 3, stage 5. Okay. See, now we are getting the output. But see, the here it is saying stop the top customer job. This code is running. This job is running. This job is not terminated. Now if I want to see my DAC, if I hit this thing, we can see the DAC. This is my DAC. This is my username. This is my job. This is my job. Go to this thing. Go to tag visualization. See text file. Then we are doing partition by, if you don't know partition, it's internally it is happening. Okay. Then map partition this. Okay, this is our job. This is our top customer.py file. But one thing I want to tell, if you want to visualize your code using DAC, you should write Scala code, not Pyspark, because the execution process of Scala and Pyspark is different. So when you are writing same code for Pyspark and for Scala, you will get, for same code you will get different type of DAC, because the Spark engine when your Spark engine is written in Scala. Okay, so the Scala code is executing directly by the Spark engine, but when you are writing Pyspark code, the Pyspark code is first converting using some API. Pyspark code is converting into Scala, then that is executing by Spark engine. So there is some difference in execution in Spark code and Scala's code. Okay, Apache Spark like Pyspark code in Apache Spark means Scala's code. So for that scenario, you will get some different thing. Okay, different DAG. So from this DAG you cannot understand what is happening. But if you write same code in Scala, you will get clear understanding. That thing I will come. I will explain the DAG thing the later video. Okay. Now you will see. So you can go through this thing. Number of tasks to duration 1 second. How many read? If you know the supple thing, how internally my Bluetooth work, you can understand these things. Okay. Now stage, storage, you can go through these things. Environment, executor. If you know the architecture, you can go through this. I will explain this thing later. Okay. So for this video, that's it now. Okay, I already told you how to write the Pyspark code for this for this problem statement. If you want to see Scala's code, I can also write Scala's code here, but I will not write Scala's code. I have that Scala's code, so I'll just show you. Okay, the Scala's code for this problem statement. So Scala's code, if you want to see Scala's code, let me open my Scala ID. I'll show you Scala to be in the same thing, but the syntax will be different. Okay, here we are using lambda function. There we have to use arrow like equal, then arrow sign. What we called in math tends to. Waiting for some time, it is taking time. So this code will be available in my GitHub. Scala's code also same thing. Also Pyspark code. You can take this code and dataset from my GitHub repo. Okay, it is opening. This is my thing. Okay, let me enter. Though how the Scala code will look like, I will show you. That's it. That's how Scala code will look like. Okay, we are setting logger here. Then we are trying to read the data from this path. Then we're trying to split it. Then trying to use reduce by key. And then we are trying to use sort by. And then collect, then printing. Same thing, syntax is different. Okay, syntax is different. So that's it. I will put both code. I'll upload both code in my GitHub. You can check that from my GitHub. So that's it in this video. See you in the next video. Bye. Have a good day.